We will answering the two examples of the assignment. First, we will answer the ordinal attribute. Ordinal attribute means whether we having ascending order or descending order information. To answering ordinal attribute, we will need three steps. First step, we will count states here. In this example, we have three states: fair and good and excellent. Then the MF equals 3. Step 2, replace each ordinal data of test 2 by rank fair equal 1 and good equal 2 and excellent equal 3. Step 3, normalize the ranking. The formula rule equal Z1F equal rank minus 1 over MF all attribute minus 1. Then we will calculate the attribute for fair, that we give it 1 equal 1 minus 1 over 3 minus 1. Then we get 0. Then we will calculate attribute for good. Good 2 equal 2 minus 1 over 3 minus 1. Then we will get half. Then we will calculate the attribute for excellent. Equal 3 minus 1. Excellent of attribute 3 rank 3 3 minus 1 over 3 minus 1. Then we will get 1. Then we will update our data matrix by this table, their object and identifiers, and their ordinal attribute. Ordinal attribute of 1, then we will get 1. First excellent. The ordinal attribute of 2, then we will get 0. Ordinal attribute of 3, then we will get 0.5. Ordinal attribute of 4, then we will get 1. Then we will using Manhattan. To calculate this distance. Manhattan distance dxy equal absolute x1 minus y1 plus x2 minus y2 plus xn minus yn. Then we will calculate the distance matrix. The distance matrix, we will calculate it. We will give 1, 2, 3, 4. 1, 2, 3, and 4. First, we will put zeros of these similarities: 0, 0, between 1 and 1, between 2 and 2, between 3 and 3, between 4 and 4. Then we will calculate each distance point alone. First distance to between 2 and 1 equal absolute 0 minus 1 equal 1. We get this distance of this table of between object and ordinal attribute. Between 0, between 1 and between 2 and 1, 0 minus 1, Then we will get distance between 3 and 1 from either the table. 0.5 minus 1 equal 0.5. Then we will calculate distance between 4 and 1. 1 minus 1 absolute equal 0. Then we will calculate distance between 3 and 2 equal 0.5 minus 0 equal 0.5. Then we will calculate distance between 4 and 2. Distance between 4 and 2 either equal absolute 1 minus 0 equal 1. Distance between 4 and 3 equal absolute 1 minus 0.5. Then we will get 0.5. We calculated all this distance, put it in this distance matrix. We will get between 2 and 1 1. We will get between 3 and 1 0.5. We will get between 4 and 1 0. We will get between 3 and 2 0.5. We will get between 4 and 2 distance equal 1. Distance between 4 and 3 equal 0.5. We calculated all distance matrix of ordinal attribute. In second example, we will calculate the dissimilarity matrix for a mixed attribute. To calculate the dissimilarity matrix for a mixed attribute, we must know three attributes: nominal attribute and ordinal attribute and numerical attribute. We will consider all attributes that we will have which are different types. We worked the dissimilarity matrix for each individual attribute. The procedures we followed for test 1, which is nominal, and test 2, which are ordinal. Then we will calculate test 3, numerical attribute. We will calculate numerical attribute by a formula dij equal absolute xi minus xj over max minus minimum. Max there is in this example is 64 and the minimum equal 22. We must calculate it in a table id and test 3. Test 3 in this example, total id 1 2 3 4 test 3 45 22 64 and 28. To calculate the dig, let d of 2 and 1 equal absolute 45 minus 2 and 1, absolute 45 minus 22 over 64 minus 22. Then we get 0.55. Then we will calculate that table of numerical attribute, dissimilarity matrix for numerical attribute. Then we put zeros between 1 and 1, 2 and 2, 3 and 3, 4 and 4. Then we calculate between 2 and 1, we get 0.55. Calculate each dij by this rule. Then we get between 3 and 1 0.45 and between 4 and 1 0.40. Then we get between 3 and 2 1 and so on. Then to calculate mixed attribute, we must know this formula: dij equals sigma f1 b delta ij dij over sigma f1 b delta ij. We must know very important note: if delta ij equals 0, data is missing in this table of a mixed attribute. Between there is most data is missing in nominal or ordinal or numerical. Then delta ij equals 0. Delta ij equal 1, then otherwise. Then we calculate the delta ij for 2 and 1 in the mixed attribute between 1 times 1 plus 1 times 1 plus 1 times 0.5 over 1 plus 1 plus 1. Then we get this dij between 2 and 1. Then we calculate each element in this dissimilarity matrix to get this matrix: 0, 0.55, 0.